Welcome back to the Health Science Channel GH. In this video, we are going to talk about sampling procedure in research methodology. Sampling procedure in research methodology. Now, sampling procedure is a very important topic for students, especially researchers, students writing their proposal, students working on their project works or their actual project works, theses or dissertations. Okay, now by the end of this video, you would understand one, what sampling procedure means. Again, you would also understand the types of sampling methods. Okay, now I would also take you through clear practical examples for each of the sampling procedures or sampling methods. Okay, and lastly, you would understand the meaning and importance of what we call sampling frame in research methodology. Now, let's begin with sampling procedure. What sampling procedure means. Now, when we say sampling procedure basically refers to the process and the techniques that is used by researchers, okay, to select a portion. The portion is what we call a sample from a larger group known as a population. Okay, so you remember that in research, you would have what we call a study population or a target population. But usually, you will not collect data from all the group or the individuals within your target population. Okay, you would get a sample, okay, and you would only collect your data from or gather your information from the sample. Okay, now when we say a sampling procedure, the process and the techniques that is used by the researcher to select a portion, okay, that portion from the known population or that portion from your target population that you are selecting using the sampling procedure, that is what we call a sample. Okay, great. Now, and that is why sampling procedure is very important. Now, in simple terms, what this means is that sampling procedure means selecting a small group of people from a larger population, okay, so that we can study them and make conclusion about the entire population. Is that okay? And so that should tell you that sampling procedure is very important. Okay, let's look at some practical examples. For example, if you want to study, let's say, the health habits of 10,000 adults in a city. Let's say you want to conduct a study among adults in a city. We have 10,000 adults within the city. Okay, you would understand that it is not realistic to study everyone in the city, all the adults in the city. It's not realistic. Okay, so instead, you are going to select, let's say, 400 to 500 people who would represent the population. Okay, now the process of selecting those people is what we call sampling procedure. Is that okay? The process of selecting a group of people from within your population, okay, that process of selecting a portion from within your population, that is what we call sampling procedure. Okay, now why do we use sampling, or why do you have to do sampling in research? Okay, why sampling? Okay, now sampling is going to help you, one, to save time. Again, sampling would also help to reduce cost, because imagine that for the example that I gave, you want to study the health habits of 10,000 adults in a city. Imagine you have to collect data from all the 10,000 people. That is going to be a lot of work. That would require a lot of resources. Okay, so sampling is very important. One, to save time. Two, to reduce cost. Three, to make research manageable. And lastly, to help you to still get reliable and valid results. Okay, that's the reason why we do sampling in research. Okay, so basically sampling is a process. Okay, it's a process and the techniques that is used by a researcher to select a portion called called a sample from a larger group known as the population. Okay, so like I said, in simple terms, sampling means selecting a small group of people from a larger population so that we can study them and make conclusions about the larger or the entire population. So the example that I gave, you want to study the health habits of 10,000 adults in a city. You have to get it that it's not realistic to study everyone, the 10,000 people. So instead of studying the 10,000 people, you find a way to select 400 or let's say 500 people. And that 500 people, you conduct the process of selection of that 500 or 400 people such that it represents the entire population. Now, that process of selecting those people is what we call sampling procedure. Now, there are times that some writers or in some literatures, they call it sampling. It's the same thing. So when you hear sampling in research, it's the same as sampling procedure. Is that okay? And like I said, sampling is very important because it saves time, it reduces cost, it makes research manageable, and it helps you, the researcher, to still get reliable and valid results, even though you are not going to use the larger population. But in conducting a sampling, you'd be able to still get reliable and valid results. Now, there are two main types. Let's look at types of sampling procedures or sampling methods or sampling techniques. Now, sampling methods are broadly divided into two main types. Sampling methods, they are broadly divided into two main types. Okay, we have probability sampling and then we have non-probability sampling. So in research and also in statistics, we have two broad divisions of sampling methods or sampling techniques or sampling. So we have two main types of sampling or two broad divisions of sampling or two main types of sampling techniques or sampling procedure. The first one is the probability sampling technique or sampling method, and the second one is the non-probability sampling. So we have non-probability sampling and we have the probability sampling. Now, what is a probability sampling? What is the meaning of probability sampling? Now, in probability sampling, every member of the population has a known and equal chance of being selected. That is the simplest explanation. So when we say probability sampling, okay, every member, so in probability sampling, every member of the population has a known and equal chance of being selected. Okay, now basically, this type of sampling, probability sampling, is scientific. Again, it is objective, and it also allows us to generalize our findings to the entire population. Okay, so probability sampling is very interesting. Okay, so the key thing with probability sampling is that there's the type of or a form of sampling where every member within the population has a known and equal chance of being selected. The underlined word over here with probability sampling is that because you see, in sampling, during sampling or in sampling procedure, we have a population, but we can't use the entire population. So we use a certain process to get a portion from the population. But at the end of the day, the portion should be a representation of the larger population. Now, that process of getting that portion is what we call the sampling procedure or the sampling technique. But then in forming the portion, we have two ways or two broad ways we can get that portion out of the population. Now, the first method is the probability sampling. Now, in probability sampling, you see, we are forming our sample or the portion from the population. In probability sampling, every member within the larger population have a known and an equal chance of being part of the sample or the portion. Okay, that is what we mean by probability sampling. Okay, and probability sampling is scientific. It is very objective. And one key strength of probability sampling is the fact that it allows researchers to generalize their findings to the entire population. Okay, now we will move forward and we'll look at subtypes of probability sampling techniques. Subtypes of probability sampling techniques. Okay, good. Let's look at some subtype of probability sampling. Now, with a subtype of probability sampling, we have simple random sampling. The second subtype, we have systematic sampling. Third, we have stratified sampling. Okay, and lastly, we have the cluster sampling. Okay, so we have four common subtypes of probability sampling. The first one, we have the simple random sampling. The second one, we have the systematic sampling. The third one, we have the stratified sampling. And then the last one, we have the cluster sampling. Now, let's look at each of the subtypes of probability sampling. Then we'll go through it and look at practical examples and how you can apply that in research. Now, what is simple random sampling? Simple random sampling is a type of probability sampling procedure or technique. Now, in simple random sampling, every individual has an equal chance of being selected. Now, let's look at it practically. Okay, let's say you have a class of 100 students. This is a simple example. You have a class of 100 students and you need to select 20 students for a study. You have a class of 100 students. You need to select 20 students for a study. Okay, and we are going to use probability sampling, specifically simple random sampling. This is how you are going to go about it. All you are going to do is that you write all the 100 students, the names of all the 100 students. Then you assign numbers to it. Numbers 1 to 100. So you write the names of all the 100 students. You assign numbers 1 to 100. Okay, now we are using simple random sampling. So the next thing you are going to do is you use a random number table or a computer to pick 20 numbers randomly. Simple as that. Okay, so whoever's number appear is selected. So in this situation, you realize that there is no favoritism, there is no bias. Okay, that's what we call simple random sampling. Okay, so you have a class of, let's say, 100 students, and you want to select 20 students to take part in a study. Now, you are going to write the names of all the 100 students, then you assign numbers to it, numbers 1 to 100. Okay, then you use random number table, or you can use a computer to pick up 20 numbers randomly. Is that okay? You don't follow any pattern. You just pick 20 numbers randomly. Okay, so whoever's number appear is selected. So in this situation, you realize that you didn't select them using their names. So you see, that means that every person have an equal chance of being selected. So there is no favoritism and there is no bias. Okay, this type of sampling is what we call simple random sampling. Now, when do we use simple random sampling? Okay, we use simple random sampling when a complete population list is available. When the population list, a complete population list is available. Again, we use simple random sampling when the population is fairly homogeneous. The population is fairly homogeneous. That is when we use simple random sampling. Now, let's move on to systematic sampling. Systematic sampling. Now, what is systematic sampling? Now, systematic sampling is also a subtype of probability sampling. In systematic sampling, what we do is that we select every case individual after a random start. Okay, we select every case individual after a random start. Let's look at a practical example. Now, suppose a hospital register has 1,000 patients and you want to select 100 patients. Now, if you want to use a systematic sampling approach, this is what you are going to do. You first of all, you divide the population by the sample size. Okay. Now, the hospital register is how many patients? 1,000 patients. How many patients do you want to select as portion from the population? 100 patients. Now, if you want to use systematic, what you are going to do is, first of all, divide the sample size that you want. Okay, so divide the population by the sample size that you want. So this is going to be 1,000 divided by 100. That will be 10. So that means that you are going to randomly select a starting number between 1 and 10. Okay, so say 3. So let's say so this would be like, so first of all, you select the 10th patient. The 10th patient. So you randomly start from, let's say, so this is how you are going to do. So with a systematic sampling, we have a hospital register has 1,000 patients, and you want to select 100 patients. You want to use systematic. First, divide 1,000 by the 100. You get 10. Now, when you get the 10, what you are going to do is that, now, start from any number. You can start from, let's say, the third count. Okay, you have the register, so you start from the third count. Now, when you start from the third count, so you count 1, 3, 4, 5, 6, 7, 8, 9, 10. When you get to the 10th person, then you take that number down. Then from the 10th person, you count another 10. Then you take. Okay, so you are going to select the kth individual. How do you get the kth individual? By dividing the population within the registry by the sample size that you are expecting, or the portion that you are expecting. So the step is that you divide the population by the sample size. So in this example that I gave, the population is 1,000. The sample size we want is 100. So 1,000 divided by 100, that will give us 10. So randomly select any starting number. You can start from 2. You can start from 3. You can start from 4. Okay, so when you choose to start from 4, then what it means is that the kth is now 10. Okay, so you randomly start from any number you want. You can start from 2, you can start from 3, you can start from 1, you can start from 4. So if you choose to start from 3, what it means is that 3, 4, 5, 6, 7. So you choose the third person. That will be the first person. Now, the next person, you count 3, 4, 5, 6, 7, 8, 9, 10. The next person will be the 10th person. From the 10th person, okay, so you count 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You get? So after counting 10, the next person will be the 13th person. Is that okay? Then the next person will be the 23rd person. Then you add another 10. The next person will be the 33rd person, and so on and so forth. Is that okay? That is how we do systematic sampling. Okay, so in systematic sampling, we select the kth individual after a random start. So you randomly select the first person. That's the principle. Okay, so a practical example that I gave is, for example, you have 1,000 patients on the ward. You want to select 100 patients. First of all, you divide the 1,000 patients by the 100. You get 10. So the kth, that's the interval, is 10. So randomly, let's start from the third person. If you start from the third person, it means the next person will be the 13th person. Okay. If you started from, let's say, the 4th person, meaning the next person will be the 14th person. Okay. Then after the 14th person, the next person will be the 24th person. After the 24th person, the next person will be the 34th person. You keep on adding the kth, the 10th. And how do you get the kth? You get the kth by dividing the sample size that you are expecting. Dividing the population by the sample size that you are expecting. Okay, but remember that the principle is that the first person is randomly selected, or the first number is randomly selected. The first number is randomly selected. Then the subsequent numbers are gotten by adding the kth number, or the kth, the kth, okay, to the randomly selected number. Now, when do we use systematic sampling? We use systematic sampling when the population is ordered. Again, when you want something simple and quick, a quick way of doing sampling, one of the easiest way to use is the systematic sampling. Now, let's move on to the stratified sampling. Stratified sampling. Now, remember that stratified sampling is also a subtype of probability sampling technique. Now, in stratified sampling, the population is divided into subgroups called strata, such as gender, age, or profession. Okay, and samples are then taken from each group. Now, a typical example: suppose a university has 60% female and then 40% male students. Okay, now there's the step you are going to use if you want to do stratified sampling. Divide the students into male and female groups. Then now when you divide the students into male and female groups, select samples proportionately from each strata. Select samples proportionately from each strata. Now what this means is that this is going to ensure that both males and females are properly represented. Okay, that's the essence of stratified sampling. Okay, so in stratified sampling, the population is going to be divided into subgroups. We call it strata, such as the gender, the age, or the profession. Now, samples are then taken from each group. Now, suppose a university has 60% female students and 40% male students. The steps you are going to use if you want to use a stratified sampling technique is you have to first of all divide the students into male and female groups. Then you go further to select samples proportionately from each group. And the next thing you are going to do is that these two processes that you're observing is going to ensure that both the male student and the female student are properly represented. There wouldn't be, bias in terms of the representation. Okay, good. And that technique is what we call stratified sampling technique. Okay, now when do we use stratified sampling technique? When the population has important subgroups. Okay, and you still want to consider representation, or you want to factor in equal representation or fairness in representation. Now, the last subtype of probability sampling is cluster sampling. Now, cluster sampling is very simple. In cluster sampling, the population is divided into two clusters, such as schools, let's say hospitals, or communities. Okay, now with cluster sampling, instead of selecting individuals, we randomly select the entire cluster. Now, a typical example, if you want to study, let's say, primary school pupils in a large state with, let's say, 500 schools. Now, there's the step we are going to use if you want to do cluster sampling. What we are going to do is that we will divide the schools into clusters. Okay, then we will randomly select 20 schools. Then we study all the pupils in those selected schools. Okay, now when do we use cluster sampling? Cluster sampling is very important when the population is very large. Again, the population is geographically dispersed. The best sampling technique to use is the cluster sampling. So cluster sampling is when in cluster sampling, the population is going to be put into clusters. So for example, maybe schools, hospitals, or communities. So instead of selecting individuals from the schools, okay, we randomly select the entire cluster, the larger cluster. Okay, so you want to do a larger study in multiple schools. Is that okay? In a certain community or a certain district or a region. Okay, instead of selecting the individuals directly from the facility, put them into clusters. Before, within the clusters, you select the individuals to partake in the study. Okay, and with cluster sampling, for example, the example that I gave, very simple. You want to study primary school people in a larger state, let's say 500 schools in the state. You can't go and select people from all the 500 schools, individuals from the no. So first of all, form clusters first, divide the schools into clusters first. Then randomly you select 20 schools randomly using random sampling to select 20 schools. Then you study all pupils in the selected schools. So you are going to study the pupils within the selected schools. Okay, and so cluster sampling is very important when the population size is very large, and also when the population is geographically dispersed. Okay, now let's move on to the non-probability sampling. Non-probability sampling. Now, in non-probability sampling, not every member of the population has a known or equal chance of being selected. Not every member, unlike the probability sampling that every member has an equal chance and a known chance of being part of the sample. In non-probability sampling, not every member of the population has a known or equal chance of being selected. In fact, this method is used when random selection is difficult or not possible. Okay, great. Now, with non-probability sampling, we have subtypes of non-probability sampling as well. One of them is convenience sampling. Okay, we also have the purposive sampling. We have another sampling. We have the snowball sampling, and we have the quota sampling. The quota sampling. Okay, now let's start with the convenience sampling. Convenience sampling. Now, what is convenience sampling? Convenience sampling basically involves selecting participants who are easily available. So when we say convenience sampling, it basically involves selecting participants who are easily available. Now, a practical example is a researcher interviews patients who come to, let's say, the clinic, who came to the clinic that day because they are easily accessible. It's a typical example of convenience sampling. Yes, of course, we want to conduct a study. Those who are available, we use them. That is convenience sampling. Convenience because we use those who were available. Is that okay? But you know, over here, not every member that may fall within their target population may have equal chance. The members within their target or study population or their inclusion criteria may not have equal chance of being part of the study. Okay, that's why we say it's a subtype of non-probability sampling. Okay, good. Now, when do we use convenience sampling? Usually, for example, if you are doing a pilot study, sometimes they mostly use convenience sampling in pilot studies. Okay, and mostly in exploratory studies, in qualitative studies, they sometimes use convenience sampling in qualitative studies. Okay, great. So in convenience sampling, it involves selecting participants who are easily available. Okay, so if you listen to the name, convenience, so participants who are available to partake in your study, you use them. That is convenience sampling. Now, purposive sampling. In purposive sampling, okay, the participants are selected based on the researcher's judgment. The participants are selected based on the researcher's judgment. Now, when we finish going through purposive sampling, I will now let you understand the difference between the purposive sampling and convenience sampling. They are two different things. Okay, now with the purposive sampling, participants are selected based on the researcher's judgment. Now, if you are studying the experiences of diabetic patients, you purposely select people who are living with diabetes. People that you think, you know, they have the characteristics that you want to study. That is purposive sampling. Okay, so in purposive sampling, participants are selected based on the researcher's judgment. For example, you are studying the experiences of diabetic patients. You purposely select people who are living with diabetes. That is different from convenience sampling. Convenience sampling involves selecting participants who are easily available. Okay, but with purposive sampling, you select participants based on your judgment. Judgment in terms of people that you think they are connected with your study. They have the answers that you want. They are relevant, okay, in terms of giving you the information that you want. Okay, and mostly we use, just like convenience sampling, purposive sampling is also used in qualitative research or exploratory research, and also in case studies. Okay, now the next non-probability subtype is the snowball sampling. Now, in snowball sampling, existing participants helps to recruit new participants. Very simple. That is what we call snowball sampling. snowball. Existing participants help to recruit new participants. For example, if you are studying substance users, okay, if you are studying substance users, it's not easy to come by those people. Okay, but then the good thing is that one participant refers you to another participant. So when you're able to meet one participant, that participant is able to connect you to another participant. Okay, and it is true that you are going to get your sample. Okay, and that type of sampling procedure is what we call snowballing, where one participant is connecting you or referring you to another participant. Okay, such a sampling procedure is what we call the snowball sampling. Okay, so existing participants help to recruit new participants. So you are studying substance users, or maybe let's say prostitutes. You are doing a study among prostitutes or sex workers. Okay, one sex worker can refer you to another sex worker. Is that okay? Such a study is what we call such a sampling procedure is what we call snowball sampling. Okay, and mostly we use this for hidden or hard to reach population. You are conducting a study in hard to reach population or hidden population. The best sampling procedure to use is snowball sampling procedure. Now, the last sampling procedure under non-probability sampling is the quota sampling. Now, what is quota sampling? Quota sampling basically involves selecting participants until a required number for each subgroup is reached. Selecting participants until a required number for each subgroup is reached. Now, example is a researcher decides to interview, let's say, 50 male, and then 50 males, and 50 females. Now, regardless of how they are going to be selected, that is what we call quota sampling. You give a quota. Okay, so that is why I mentioned earlier that quota sampling involves selecting participants until the required number for each subgroup is reached. So you have a required number. So right from the start, you have a required number that, okay, the required number of females I need is 50. The required number of males I need is 50. Okay, so you, the researcher, since you are using quota sampling, your focus is not how you are going to, your focus is to meet your quota, the 50-50. Let's say you are going to do a study in a school. Then you decide to use a quota sampling that, okay, I will use 50 males, 50 females. Now you keep on selecting the males until, you get your 50 males and 50 females. What is guiding you is the quota. Okay, such a sampling procedure is what we call the quota sampling procedure. So in quota sampling procedure, it involves selecting participants until a required number for each group is reached. A practical example, a researcher, you want to interview 50 males, 50 females. Now, regardless of how you are going to, in quota sampling, we do not care how you are going to get the 50. All that is important, or the key principle, is that the quota that you set at the beginning of the sampling, when you get to that quota, you end. That is what we call quota sampling. Is that okay? Great. So, quota sampling is used when representation is important. You want to consider representation, but you don't really want to do anything like random selection. Then you use quota sampling. All you need is you are getting the representation. If the groups, if let's say male and female, you want 50, female you want 50, that is your interest. The quota is your interest. You are not interested in the randomization. The random selection. Then the best sampling technique to use is the quota sampling technique. Now let's look at sampling frame. Now, when we say a sampling frame in research methods, sampling frame is more like a complete list or a database of all members of the population from which a sample is drawn. For example of sample frame. Example can be, let's say, hospital patients register. Okay, That is an example of a sampling frame. A sampling frame is a complete list or a database of all the members of the population from which you draw your sample from. That complete list of the database of all the members within your population, that is what we call a sampling frame. So for example, you want to conduct a study among patients in, let's say, an emergency unit. Now the hospital patient register, okay, provided it contains the complete list of all the patients, it becomes the sampling frame. Another example, class attendance list. You want to conduct a study among students in a certain school, maybe a junior high school, maybe among level 4 or 400 students. Okay, now the class attendance list can serve as a sampling frame. Why? Because it contains the complete list of that student, and usually it's out of the sampling frame that we get the sample. It is out of the sampling frame that we get the sample. Is that okay? Good. So the sampling frame is more like a complete list of the entire population. Okay, so if we have the population, we get the sampling frame from the population. The sampling frame is like a complete list. Is that okay? Of the population, especially the population that meets your inclusion criteria. That's the sampling frame. Okay, a sampling frame can be staff nominal roll or school enrollment records. Okay, so it is out of the sampling frame that you draw your sample from. Is that okay? Now, the importance of a sampling frame is that the sampling frame ensures everyone has a chance of selection, especially when you are using probability sampling. Again, sampling frame can help define the study population clearly. And lastly, sampling frame also improves accuracy and reduces bias. Okay, now how can you form a sampling frame in research? What steps can you observe to form a sampling frame? Now, first of all, clearly define your target population. For you to be able to have a sampling frame, clearly define your target population. Secondly, apply your inclusion and exclusion criteria. Because see, when you have your target population, okay, now after establishing your target population, okay, you have to apply your inclusion and exclusion criteria, and that would help you to update the list before you now get the sampling frame. Is that okay? And usually it's out of the sampling frame that you draw your sample from. Is that okay? Great. So basically that is what we call a sampling frame. Okay, so a sampling frame is a complete list or a database of all the members of the population from which a sample is drawn. A typical example, I gave you an example. Example can be hospital patient register. So for example, you want to do a study among patients visiting, let's say, the antenatal clinic of a hospital. Now the antenatal clinic register, okay, the antenatal clinic registry or the register, is that okay? Is a sampling frame. Why? Because it contains a complete list or the database of all the members of the population. Now, if you have that register, you can draw your sample from that register. Is that okay? Class attendance. You want to do a study among, let's say, level 400 students in a certain nursing training institution. Now, the school register of the level 400 students, that becomes your sampling frame. Why? It's a complete list, or it contains the database of all the members in the population. And it is out of that sampling frame that you can draw your sample from by applying either a probability sampling procedure or a non-probability sampling procedure. Is that okay? Great. And sampling frame is very important, especially when you want to use probability sampling. It's very, very important when you want to use probability sampling. Is that okay? Sampling frame is very, very important when you want to use probability sampling. Okay, Good. So we've been looking at sampling. Okay. So like I said, we have two main types of, or broad types of sampling. We have the probability sampling and we have the non-probability sampling. And I mentioned that in probability sampling, every member of the population has a known and equal chance of being selected. Now, this type of sampling technique is scientific, it is very objective, and it allows for generalization of our findings to an entire population. Now, the types of, or the subtypes of probability sampling, we have simple random sampling, we have systematic sampling, we have stratified sampling, and we have cluster sampling. And I explained that when we say simple random sampling, every individual has an equal chance of being selected. And I give practical example. Let's say you have 100 students and you need to select 20 students for a study. Just write all the 100 students, their names, or assign numbers 1 up to 100. Then you use random number table or a computer generated random number table to pick 20 numbers randomly. So whoever's number appears is selected. So in this situation, you realize there is no favoritism and there is no bias. Okay, so if you look at the diagram over here, so you see simple random sampling. Okay, so we randomly select. So you see we randomly select 1, 2, 3, 4, 5. We randomly selected 5 people. Is that okay? Yes, this is what we call simple random sampling. Now let's look at the systematic sampling. Now in the systematic sampling, we select the cave individual after a random start. Okay, so you can randomly say that, okay, you give all your target population, you give them numbers. Then you can randomly start from the third person. But you need the cave individual to get the next person. How do you get a cave individual? For example, suppose a hospital register has, let's say, 1,000 patients. And you need 100 patients. Now divide the 1,000 by 100, you get 10. Now randomly, in selecting the first person, randomly choose any number. So you can randomly start with the third person. Now, after choosing the first person randomly, the next person add 10 to the third. That will be 13th person. So that the second person will be the 13th person. Now, to get the third person, add the 10 to the 13th person. That will be the 23rd person. Okay, so you see, we are getting subsequent numbers using the cave term. Is that okay? That's the principle in systematic sampling. Is that okay? So you see over here, we have the one. If you look at the diagram over here, the first person was randomly selected. The second person was randomly selected. So the third person, 1, 2, 3. So we use 3 intervals. 3. So after getting to, so the second person was 1, 2, 3. So that means the next person will be, you count another 3, 1, 2, 3. The next person to will be another 3, 1, 2, 3. The next person to will be another 3, 1, 2, 3. So you see the interval here is third term. Is that okay? That's systematic sampling. Okay, but then the first person is always randomly selected. So here they randomly started with the second person. Okay, now the next probability sampling we discuss is the stratified sampling. In stratified sampling, the population is divided into subgroups called the strata, such as gender, the age, or the profession, and samples are taken from each group. So suppose a university has, let's say, 60 female students and 40 male students. You divide the students into male, female, then you select samples proportionately from each group. Is that okay? Great. So you see over here stratified sampling. So you see stratified sampling, they've placed the groups into strata, the subgroups into strata. Then they select. Is that okay? Then they select the sample proportionately from each subgroup. Then the last subtype of probability sampling is the cluster sampling. In cluster sampling, as I explained earlier, the population is divided into clusters. Okay, so you see we put the population into clusters. Okay, then at the end of the day, after putting the population into clusters, you randomly select the clusters. Then within the clusters, you select the individuals to partake in the study. That is cluster sampling. So instead of selecting the individuals directly from the subgroups, you randomly select the entire clusters. Okay, good. So if you want to study primary schools in a larger state, let's say we have 500 schools, you can go and do random selection from all the students in the 500 schools. So you have to first of all, randomly select the entire cluster. So for example, if let's say you need 20 schools, you randomly select the 20 schools. Okay, so you randomly select the 20 schools. Then you study all the pupils within those selected schools. That's all. And we use cluster. Cluster sampling is very important when you are dealing with a very large population, and also situations where the population is geographically dispersed. The best, sampling technique to use is the cluster sampling technique. Now, in summary, sampling helps researchers to study a small group to understand a larger population. Now, choosing the correct sampling method is very important for the validity of a research. Okay. Now, and so when you are doing sampling technique or sampling procedure or sampling in research, you have to be very careful and make sure you choose or you select the right sampling technique. Now, mostly in quantitative study, it's very advisable that you use probability sampling in quantitative studies. Okay. Now, in exploratory or in qualitative study, you can use the purposive sampling or the convenient sampling approach. Okay, great. Now, I think this brings us to the end of sampling procedure or sampling technique, the part 1. I'll do another video to, take you through some practical steps, especially with how to deal with stratified sampling, how to calculate the cave term, and all the other, especially with the quota sampling as well in the non-probability sampling. Okay, now if you found this video helpful, please make sure you share this video with your friends who are also studying research method, who are also working on their proposals, their dissertations. Do well to subscribe to the channel. Drop your questions in the comments section and I'll respond in due time. I wish you all the best. Catch you in the next video. Bye bye.